In this problem, we are asked to determine which statements are true. Let's take a look at our table. Our x values are increasing by 1. Let's look at our f of x values. From 4 to 0 is minus 4. 0 to negative 12 is minus 12. Negative 12 to negative 32 is minus 20. Negative 32 to negative 60 is minus 28. So it's definitely not a linear function. Let's look at our second difference. Negative 4 to negative 12 is minus 8. Negative 12 to negative 20 is minus 8. Negative 20 to negative 28 is minus 8. We can conclude that this is a quadratic function with a second difference of minus 8. Now that we know that, let's take a look at our statements to see which ones are true. Our first statement is the minimum value is 0. That's asking us to find the vertex. So it is assuming that 0, 0 would be our vertex. But if I look at this and I look at my first difference, is negative 4 to negative 12, negative 20, negative 28. That is decreasing. Also, around 0, there's not symmetry. The f of x value at negative 1 was 4, and the f of x value at 1 was negative 12. So I know that 0, 0 is not the vertex. So therefore, it doesn't have a minimum value of 0. Additionally, I have values for f of x that are less than 0. I have negative 12, negative 32, and negative 60. There are lots of values that are lower than 0, so the minimum value of 0 is definitely false. Let's take a look at the axis of symmetry as x equals negative 1. So this is proposing that my vertex has an x value of negative 1, which would mean that my vertex is negative 1, 4. So let's check that. If that is the vertex, I would need to see symmetry around that point. So I'd have to back the table up another step to see if there was symmetry. So let's back up the table to negative 2. Now, if negative 1, 4 was the vertex, I should get an f of x value of 0, so that way I have symmetry around that f of x value of 4. Let's check and see if that value of 0 really works. So from 0 to 4 would be plus 4, and that would give me a second difference of 4 to negative 4 of minus 8. So it looks like this value of 4 for f of x is our vertex point, and it is our maximum because we do have symmetry around that point. So our axis of symmetry is at x equals negative 1 because our vertex, which is a maximum, is at negative 1, 4. All right, the x-intercepts are at x equals 0 and x equals negative 2. So remember, at the x-intercepts, our y value must be 0. So I'm looking where f of x is equal to 0. All right, so if I look here, f of x is equal to 0 at negative 2, and f of x is equal to 0 at 0. So that is a true statement. Our final statement is the y-intercept is 0, 0. That is also a true statement because that point at the origin lies on the x-axis and the y-axis. So it's serving in both capacities as the x-intercept and as the y-intercept.